Day 33, and we're going to move to our math lessons. Of course, I hope you're doing the other lessons as they come by. We're going to jump to our windows first. Math windows, we're on page 511 in day 43. Okay. So we got numbers, a set of numbers, and we have to find the mean, the median, and the mode. We've done a number of these now. We're going to skip the mean because that's the meanest one. It's the hardest one. We're going to go right to the median. Okay, so the mean is the one where you have to get the average. You have to add them all up and divide by how many there are, 7. So we're going to skip that one. We're going to do the median. The median is the middle number, but it's the middle number if you line them up from least to greatest, or greatest to least, doesn't matter really. 108, those are the smallest. No, 106, sorry. 106, then there's two 108s. 108. Then we have what? 15. I think the 15. 115. Then we have a 118. I think I'm going to be short some, maybe not. 118. We need just two more. Okay, in the 20s, 120 and 124. One, two, three, four, five, six, 7 of them. So if there's 7, then we have 3 on the bottom, 3 on the top, 1 in the middle. 115. That's the middle value. So if you say there's a set of numbers and the median is 115, we know that the numbers are around. Some are lower, half are lower, and half are bigger. Again, if there was an even number, an even amount of numbers, there would be 2 in the middle. Then you have to take the average of the two numbers. And how do you get the average of two numbers? You can add them up and divide by 2, and that would give you the average of two numbers. Okay, 115. The mode is the one that's the most common, 108. Every other one has just 1, but 108 has 2. So mode is 108, the most common of the numbers. Okay, the mean, you add them all up, and you're going to divide by 7. If you add them all up and divide by 7, I got 114.1. Now, does that answer make sense? Well, let's see. It's bigger than some and smaller than others. So that's probably about right. Notice it's also very close to the median. Sometimes the mean is real close to the median. Other times it's not. If the numbers are really different from each other, then the mean might be very different from the median also. Okay. You would know this was a wrong answer if it came out something like 130 or 140. Then you say, oh, I divided by 6. I should have divided by 7. Okay. So the answer should always be somewhere in the middle of all these numbers. Number 2, 2 apples cost $20. What will 5 apples cost? This is a classic ratios problem. They give you 3 numbers. 2 apples, I'm putting apples on top, cost $20. Money on the bottom. So that means I have to put apples on the top on this side. How much will 5 apples cost? Apples on top, we want to know the money, the cost of 5 apples on the bottom. Again, to solve this, you can cross multiply. Or if you're doing it the old way, solve for x. Well, I don't like x on the bottom, so I multiply both sides by x to get rid of that x on the bottom. That would give me 2, and I multiply this side by x. Now I have x on the top is equal to x divided by x cancels, and you're left with 5. Now we want to get rid of that 20 on the bottom, so we multiply both sides by 20, and we get 2x equals 5 times 20. But that's what we said, cross multiply. See, it's cross multiply. So we're at this when we cross multiply, or when we do it this way, we end up the same place. We want x, we want 1x. To get 1x, what do? We divide by 2. So we divide this side by 2. X equals, well, you can put this in your calculator, but 20 divided by 2 is 10. 10 times 5 is 50. Costs $50. Boy, those are expensive apples. Now, the other way to solve this is just think about it. If you were in the store and you knew 2 apples cost $20, you might think, what is the cost of 1 apple? If 2 costs 20, I would divide by 2. Somehow my focus is going off here. I would divide by 2. 20 divided by 2 is $10, and I want 5 of them. 5 times 10 is $50. $50. Okay, so we're going to go on to number 3. Let's see if I shake up my camera, if I can get the focus back. And it doesn't want to look like it wants to come back. Okay, maybe picking it up some helps out. Okay, 12% of 17.5. What did I say about that word of? It usually means multiply. So you want 12%. We can't use percent when we multiply. We change it to a decimal. 12% is 12 hundredths. This is 12 hundredths. 12 hundredths. You move the decimal point 2 places. Times 17.5. And if you run that in your calculator, you get about 2.1. Okay, does that make sense? Yeah, 10% would be 1.75. It's a little bigger than that. Okay. What is the probability of choosing a marble that is not blue from a bag containing 5 red, 6 green, and 4 blue marbles? Okay, how many marbles are in the bag altogether? 5 and 6 and 4. 5 and 6 is 11 and 4 is 15. So there's 15 marbles in the bag. And we want to know the probability of choosing one that's not blue. Well, not blue would be red or green. You could add red and green, you get 11. Or you could take 15 and subtract the blue ones. Either way, you end up with 11. Now, 11/15 is my answer. And that might be one of the 4 answers they give you in multiple choice. Or they might have converted that to a decimal. If you divide 11 by 15 on your calculator, you would get 0.73. So if the answers were all decimal form, you would look for 0.73. And again, 0.73 is what? That's also the same as 73%. They might have given the answer in percent. If they give the answer in percent, it's 73%, which is almost 100% because there's way more marbles that aren't blue than are blue. Okay, so our lesson today is on volume. Volume, what's a volume? Well, we've talked about area. We talked about circumference and perimeters, which is the length. And we talked about areas, which is covering a side of something. Volume is when you fill up something. How much does something hold? How much does a 3-dimensional shape hold? So you can figure out the volume of 3-dimensional shapes. And they help you in real world problems when you're trying to figure out how much a container will hold. Okay, so read this page on volume, and it goes through some of our 3-dimensional shapes, starting with prisms, which are like boxes. And to get the volume, you do the width times the length times the height. You just multiply those 3 measurements. Now remember, the width times the length is the area of that rectangle on the bottom. And as that rectangle extends all the way up to the top, you just multiply by the height. So the formula width times the length times height is really the same as the area of the base times the height. And you remember area of the base is just width times length. Okay, so that would give you you know what? I think they're going to tell you down at the bottom of the line. Right now they're just explaining what a prism is. This is a special prism where all the sides are the same. What do we call that? A cube. And then you have this is kind of like a prism, but it's a circular base, but it extends all the way up to the top. This is called a cylinder. And then you have it looks like a circle, but it goes all the way around like a ball. This is called a sphere. That's the correct mathematical term, sphere. And down here at the bottom, it gives you the formulas for finding the volume of each of these. Starting with the prism, as we already said, the prism is the width times the length times the height. Of course, it doesn't matter which one you do, the length times the width times the height. A cube is also the width times the length times the height. But since they're all the same in a cube, they say it's S times S times S. And what is S times S times S? S cubed. They have that down here. Cube. Volume equals edge times edge times edge. They're using edge instead of side. Edge cubed. Edge cubed. Okay. Moving on to the cylinder. Now cylinder, let's see what they give us an equation. Here's the cylinder. Volume equals pi times the radius times the radius times the height. Pi r squared h. Let's look at that. That seems like a formula you might have to remember, but look. R squared, here's the radius. Here's the radius. If you square the radius and multiply it times pi, you get the area of the base. And then you just multiply it times the height. That gives you the volume. So it's really the same formula as this. It's the area of the base times the height, because that base extends all the way up to the top, the same shape. So the formula for cylinder I like to remember is the area of the base times the height. Or you could say r squared pi, that's the area of the base, times the height. The hard one to remember is the volume of a sphere. Volume of a sphere. The volume of a sphere. Well, think of the area of the circle was what? Was r squared. The area of the circle was r squared pi, right? Now, think of it going up this way as another radius. So we're going to change this to pi r cubed, which would be the area of a cylinder that's half as big as this, times, now I don't know how they get this, 4/3. The volume is equal to 4/3 pi r cubed. That's a hard one to remember. And I should also point out on the math test, on the HiSET, they do give you formulas. So I imagine if they have a problem with volume of a sphere, they would give you this formula, because this is not one that most people remember. Most people should remember the area of a circle, pi r squared, but remembering the volume of a sphere is kind of tricky because you got this number 4/3. Okay, so the rest of this exercise is going to be working on volumes of prisms, cubes, cylinders, and spheres. Practice ones. And I am not going to work on all of these because once you can do a couple of them, they're all the same. It's just a matter of plugging into your calculator the different numbers. Okay, so first they're going to look at, right now I'm on page 7 of 11. And we're looking at, my thing is upside down. I don't know why. I hope I just didn't film stuff upside down, but my numbers were upside down. Okay, 7 of 11. Find the volume of each of the rectangular prisms. Okay, so this one is 4 by 9 by 3. In a way, you can think of this base, if that's the base, you can think of it as being 3 by 9. You multiply that to get the area and then multiply it by the height. Either way, it's 3 times 4 times 9. And I came out with, is there a line here? I don't see any. I came out with 114.1. Wait a second, that's not the right one. I came out with 108. 108. Number 2, what are you going to multiply? 2 times 7 times 5. 2 times 5 is 10, times 7 is 70. By the way, they're not giving units here. Later we'll see units. But let's say this was inches. 2 inches by 7 inches by 5 inches. The answer would be 70 cubic, not square. We're doing volume, so we say cubic inches. Or sometimes they write it like this. Inches cubed. Like that with a 3, like you're raising it to the 3rd power. Okay, so you can do the rest of these on your own. It's just multiplying the 3 sides. Very simple. Cylinders are a little trickier because you're using pi. Remember, when you work with circles, and the bases here have circles. Okay. So this first one. First one, you have 6 meters as the radius. And you need the radius because you want the area of the circle times the height. The area of the circle, remember, that is pi r squared. That's the area of the circle, but you're going to multiply it times the height. And that will give you the volume of the cylinder. So, in this case, you have 6 squared pi, and the height is what? 11. So you want to multiply 11 times 3.14 times 6 times 6. Okay? If you work that out in your calculator, I got 1,243.4. Now these are meters. I could put cubic meters, or I could put meters cubed. Meters cubed. Okay? Let's see. So this one would be what? 4 times 4. I'm going to do the radius first. 4 times 4. When you're multiplying, it doesn't matter which ones you multiply first. Times pi. Don't forget pi. We're using 3.14 times 13. Now, my calculator also has a symbol pi, but we're using 3.14 because they said use 3.14. So that's what I did. And I came up with 653.12. I'll put cubic this time, cubic inches. Okay, one more. Okay, so this one's a little trickier. Watch out, because they're giving you the diameter, 10 centimeters. We want the radius. If the diameter is 10, what's the radius? 5, because it's from the middle to the outside. It's half of the diameter, 5. So we want the height. Let's do the height first time. 9 times pi, which is 3.14, times 5 squared, times 5 times 5. And if you run that through your calculator, what do you get? 706.5 centimeters cubed. Cubic centimeters. 706.5. I don't know if you can see the point there. 706.5 cubic centimeters. Okay, you can run through the rest of these using that formula. The formula of a cylinder, volume equals height times pi times the radius squared. Make sure you use the radius though. Okay? And then they have a page of spheres. Page 9 of 11 in your worksheets. Okay, so what's the formula? Volume equals 4/3, oh, that's a weird one, times pi times the radius cubed. So this one we have what? 4/3. How do you do 4/3 on the calculator? 4 divided by 3. times pi, 3.14, times the radius cubed. Oops, sorry, that's supposed to be times, I put a dot, but you can put it like that, times the radius cubed, which is 7.2 times 7.2 times 7.2. Okay, now I want to show you something you can do with your calculator. So I'm going to get my calculator up here. Here's my calculator. Oh boy. Okay, so I want what? Well, I don't know why it's dark in the background. Is my calculator making it dark, I guess? Okay, so what were the numbers here? I gotta look again. 7.2. Okay, so I want 4. Let me start with the 4/3. So I go, we gotta look at this to see it. 4 divided 3 times pi, 3.14 times 7.2 times 7.2 times 7.2. What is that? I don't want that. Okay, so I got 1,562.7. 1,562.7. Right? Is that in your screen? Yeah. Okay, but let me show you another way you could do this. So I'm going to clear this. I'm going to do 4/3 again. Can you see this? Yep. 4 divided by 3 times 3.14 times. Now I want 7.2, but instead of putting times 7.2, I'm going to use this symbol there, that symbol. See that little arrow pointing up? That means 7.2 raised to what power? Oh, I didn't want that. Okay. 7.2 to what? The third. 7.2 cubed, the radius cubed. That's the radius cubed. You use that little arrow there. And what does it come out to be? 1,562.7 when we round it. So you can use that thing. It's real helpful to use this symbol if you're raising a number to a big power. Like suppose you want 3 to the 47th. Well, you're not going to put 3 times 3 times 3 times 3 47 times. You could use this, 3 to the 47th. Anyway, okay. Going on. Number 2. So we have 11.2. So what are we going to do? Our formula is 4/3. 4 divided by 3 times pi, 3.14, times 11.2 to the third power, or 11.2 times 11.2 times 11.2. You work that one out, and I got 5,881.96. If I rounded it up to the nearest tenth, it would be 5,882.0, because this would have to go up, and the 9 goes up to 10. Okay. Anyway, you can work out the others using this basic formula, 4/3 pi r cubed. And you can do your spheres that way. And then they throw in one more page of volume practice. Okay. You got these, of course, very simple. The cylinder, you have to use your, I like to use the area of the base times the height, but it's pi r squared times the height. Here's another, not a cube. It's a little different from a cube, but it's that's called a prism, but you just multiply length with height. Same one. This one's actually a cylinder. It might look like something too big, but it is a cylinder. Again, you would do what? Pi r squared times the height. Very simple. Now we're going to go down to some word problems because that's what you're more likely to see on the test. So here you're looking at a box and it says, a rectangular box with a volume of 80 cubic feet has the length and width shown in the drawing. What is the height of the box? Well, remember the volume of a prism is equal to what? The length times the width times the height. You just multiply the three things. But look, they gave us the length and the width. They're both 4. But they didn't give us the height. We'll leave an H here. But they did tell us the volume is 80. It holds 80 cubic feet. How would you solve? You want to get H. Well, 4 times 4 is 16, right? So if I divide by 16, that should give me the height because you got 16H divided by 16 gives us H equals. If you put this in your calculator, 80 divided by 16 is 5. That means the height must be 5 feet. 5 feet. That one was interesting because in all the other problems we've done so far, we were given the dimensions of the shape. In this one, we were given the volume, and we had to find one of the missing dimensions. When you're solving problems, usually one of the variables is unknown. Often it's the final one, but sometimes it's one of the smaller ones. Okay. Number 8. A wooden crate measures 5 feet along each edge. What is the crate's volume in cubic feet? Well, if it's 5 feet along each edge, it means it's a cube. 5 times 5 times 5. 5 times 5 is 25. 5 times 25 is 5 quarters is $1.25 or 125. Last one, swimming pool problem. This one is much more likely the kind you'll see on the test because it's a real life problem. It's not just asking you for the volume of a shape. Okay. Linda adds a water stabilizer to her children's swimming pool once a week. The instructions tell her to put 1 scoop of the product for every 20 cubic feet of water. About how many scoops should she add per week? This is a real life problem because if you have a swimming pool, you have to add chlorine or something to the pool to keep the germs from growing in your pool water. And it usually it doesn't know how big your pool is, so it usually says add so much for how much volume of your pool. So you have to know the volume of your pool, how much water is in it. So we can figure out the volume of the pool when it's filled up to the top because this pool is a cylinder. It's 12 feet across. Now the volume of a cylinder is equal to the height, 5 feet, times the area of the base. And the area of the base is what? Pi times the radius squared. Now, what is the radius? It's not 12, that's the diameter. The radius is half of that, 6. So you have to be careful that you use 6. 6 squared is 36. Anyway, you can put these in your calculator. And I came up with 339.12. And unfortunately, that answer is not there, is it? What am I doing wrong? Well, I figured out the volume of the pool, but I forgot what I was trying to figure out. I was trying to figure out how many scoops of this stabilizer do I have to add to the water. Well, 1 scoop for every 20 cubic feet, but I got way more than 20 cubic feet, so I need more than 1 scoop. How many scoops do I figure out? I want to know how many of these 20s fit into that pool. So what do? Got to divide by 20. If you divide by 20 in your calculator, you should have got 16.956. And the question is about how many scoops? About how many scoops? About 17. There we go. 17. And that's it for this lesson on volumes of three-dimensional shapes.